Hello friends, today we are gathered here for the subject microprocessor unit 2 bus cycle and system architecture, in which the today's discussion point is about the 8036 DX functional pin diagram with pin descriptions and functionality of the various pins of the 386DX. This is a pinout view of the 8036DX. That means whatever the pins are arranged on an integrated chip, that is a IC of the 386DS, which are shown as a view here, just for a knowledge of all of us. This is a pin diagram for the 80386DX, okay, which has the address buses of the 32-bit, a data buses of the 13-bit, and a 2 bits A0 and A1 late for another work, and a clock signal is there. A bus control signals are there. So bus arbitration signals are there, which transfers the control of the bus to the another master whenever another master request for it. Interrupt signals are there to interrupt the current execution of the process and to request for another execution for the another processes. This is an interrupt signals are there, and byte enable signals are there. This is a 32-bit address data bus is there, and bus cycle definition signals are there with a coprocessor signaling busy error like this, and a power connection signals are there. A symbol hash symbol indicates here a active low signal. When there is no hash symbol present on the signal is active as a high. Suppose the example is the memory or a IO. The hash signal is shown here. That means a high voltage indicates the memory selected and a low voltage indicates the IO selected. So the clock signal, the input pin provides the basic system clock timing for the operation of the 386. A clock is divided by the two internally to generate the internal processor. A data bus D0 to D31, it has a three-state bidirectional signals. It can transfer a data on a 32 and a 16-bit buses using a data bus sizing features. This 32-bit line acts as a bidirectional data bus during the different access cycles. Address bus A2 to A31. These three-state output provides memory or IO port addresses. It can access a 4 GB of the physical memory from the 00H to the FFH. These are the upper 13 bits of the 32 bits which are released by the MP. A1 and A0 are used internally by the microprocessor to produce 4 bank enable signals. These two signals A0 and A1 are used to generate the 4 bank signals BE0 to BE3, which uses to enable the memory banks, which we will see a memory in a memory organization. Byte enable signals, these are the 4 memory banks. It has a 4 memory banks, indicates which byte of the 32-bit data buses are involved with the current transfer. B0 is applied to D0 to D7, BE1 bank enable signals. Applied to D8 to D15 bank enable signal 2, which is active low, applied to D16 to D23, whereas the bank enable signal B3 is applied to D24 to D31. A number of bytes enabled asserted indicates physical size of the operand being transferred. Active low 32-bit data bus is supported by the 386, and the memory system of the 8036 can be viewed as a 4 byte of the wide memory access mechanism. Bus cycle definition signal. Read write, data control, memory IO or unlock. These are the three-state outputs. A read-write is a bus cycle definition pin that distinguish a write cycle from the read cycle. Data control is a bus cycle definition pin that distinguish a data cycle, either memory or IO from the control cycle, which are interrupt acknowledge, halt, and instructions fetching. Memory or IO is a bus cycle definition pin that distinguish memory cycle from the input output pin. A log which distinguishes the bus log is a bus cycle definition pin that indicates the system have a log system bus. This distinguishes between lock and unlock bus cycles. It enables CPU to prevent other bus masters like the coprocessor from gaining a control of the system bus. So next is the bus control signals. The bus control signals indicates when a bus cycle has begun and allow other system hardware to control the addresses, pipelining, data bus width, and a bus cycle transmission. Address status, that is an ADS, indicates that a valid address is driven at 8036DS pin. It is an active when issued a valid request. The address status output pin indicates that the address bus and a bus cycle definition pins, read write, data control, memory, or B0 to B3 are carrying a respective valid signals. A transfer acknowledgement, that is a ready signal, indicates that a previous bus cycle is completed and a bus is ready for the next bus cycle. It is useful for interfacing a slow peripherals. The ready signal indicates to the CPU that a previous bus cycle has been terminated and the bus is ready for the next cycle. The signal is used to insert a wait state in a bus cycle and is useful for interfacing of the slow device with a CPU. Next address request, that is an NA. This is used to enable the address pipeline. It indicates that the system is prepared to accept the next address, even if the end of the current cycle is not being acknowledged on a ready asserted pin. This NA gives address of the next instruction if the pipelining is enabled. If the pipelining is not enabled, this pin is high, and if the instruction is in a waiting state. Bus size 16. Asserting this input constrain the current bus cycles to use only the D0 to D15 data buses. The bus arbitration signals hold and hold A. Hold input allows the another bus masters to request the control of the control bus. The hold A output indicates that the Intel 386DX has surrendered a control of its local bus to the another bus. A hold signal input pin enables the other bus masters to gain the control of the system bus if it is asserted, and a hold A bus holds the acknowledgement output indicates that the valid bus hold request has been received and the bus has been relinquished by the CPU. Interrupt signals INTR, NMI, and reset. Maskable interrupt request INTR. INTR input pin is a maskable interrupt that can be masked using the IF of the flag register. If a maskable input of that signal, the Intel thread seeks to suspend the execution of the current program and the execution of the execute and interrupt acknowledgement function. The non-maskable interrupt request NMI. The valid request signal at the non-maskable interrupt request input pin internally generates a non-maskable interrupt type 2. A non-maskable input that signals the 386DX to suspend the execution of the current program and execute the interrupt acknowledge function. And a reset pin suspend any operation in a progress and places the Intel 386DX in a non-reset state. A reset pin high at this pin input pin suspend the current operation and assert restart the execution from the starting location. This reset pin input pin suspend any operation in the progress and places the Intel 386DX in a known reset state. The Intel 386DX is reset by asserting the reset of a 15 or more clock 2 periods. When a reset is asserted, all other input pins are ignored and all other bus pins are driven to an ideal state. If a reset and hold both are asserted at the point in a time, a reset takes a priority. That means when a reset and hold, these two signals are activated at the same time, or these two signal get a signal at the same time, then the reset is a active high, that is a priority high, whereas than a hold signal. That means a reset pin having a higher priority than a hold pin. So the last pin descriptions points are the VCC and the ground. This VCC is a system power supply line, whereas the ground is a return power supply line. So with this, we'll complete the pin description for Edge Thread 6X. Thank you for watching.